What if that server room, the big cold room full of whirring machines and blinking lights, the engine of the cloud, what if you could just sort of lift it out of some remote data center and put it right next to your monitor? And we're not just talking about like a faster gaming PC here. We mean bringing genuine supercomputing level AI power directly into your personal workspace. We're looking at this new tech, the DGX Spark, and trying to figure out, well, how does moving the hardware here locally change things for serious AI work?
Yeah, it's a really interesting signal, isn't it? Shows how the hardware side is scrambling to keep up with just how fast AI itself is moving.
Yeah.
And, for people who follow this space, that DGX name
That's
probably rings a bell.
right, the big iron, the serious stuff.
Exactly. The DGX line, historically, that's been NVIDIA's top tier, the kind of gold standard for huge professional AI setups in data centers.
Yeah.
What's so fascinating, I think, with this DGX Spark is how they've taken that high-end DNA and shrunk it. You're basically getting capabilities that used to need these massive multi-million-dollar server racks. And it's designed to just, sit nicely on your desk. It's less like a standard PC and maybe more like, imagine taking a Formula One engine, something that needed a whole professional pit crew and garage,
Okay.
and packaging it neatly into something powerful,
Yeah.
but also compact, something you could actually have in your office or lab.
Okay. Okay, let's unpack that a bit, though. When you say AI supercomputer on your desk, that could sound like marketing stuff. How does that translate into real-world performance for someone, say a developer or a researcher? We saw the mention of 1 petaflop of AI power. What does that actually mean in practical terms?
That's the core of it, really.
Yeah.
1 petaflop. Yeah, it sounds abstract, but what it represents is just a massive speed up for specific machine learning tasks. The real value. It's about saving time.
Okay.
It means you could take an AI training job, something that might have taken, I don't know, a week of waiting for cloud slots, dealing with remote access, not even mentioning the bills.
Right, the scheduling nightmare.
Exactly.
Yeah.
And you turn that into maybe an afternoon's work,
Yeah.
all done right there locally. And this speed, it's not just about the chip being fast. It's the whole system being engineered for one purpose. Because it's built specifically for AI, it gets rid of bottlenecks you'd find in a general computer. You lose the sort of infinite flexibility of a giant server farm, sure, but you gain incredible efficiency for that cycle of, trying things, tweaking models, especially for deep learning or large language models.
That focus makes sense. But playing devil's advocate for a second, if you cram that much power into a small box, what's the catch? Is this thing going to sound like a 747 is parked next to me? Does it need like its own special power line just to keep the fans running?
That's a really fair question. And yeah, traditionally, that kind of compute density meant noise, heat, massive power draw, industrial scale stuff. But the engineering cleverness here seems key. While I doubt it's whisper quiet, the focus is apparently on a power-efficient design that can live in an office or lab. It's about delivering that performance without needing, say, dedicated liquid cooling pipes running through the walls or the kind of constant air conditioning its bigger siblings need in the data center. It's a pro tool, definitely built for hard work, but optimized for more normal infrastructure.
Okay, let's dive into one specific bit of that engineering that helps make it efficient. When you're dealing with these huge modern AI models, billions of parameters, right? Just moving the data around is often the slowest part. The sources mentioned this machine uses unified memory. That tackles a pretty fundamental issue, doesn't it?
Absolutely. It is a critical bottleneck, latency. Think about it like this, maybe. In a typical setup, your main processor, the CPU, and the AI workhorse, the GPU, they each have their own separate piles of memory. So if the CPU needs the GPU to chew on some data, it first has to physically copy that huge chunk of data over to the GPU's memory. Then it waits. Then the GPU sends results back. All that copying back and forth. That takes time. Adds up fast.
Okay, yeah, I can see that.
With unified memory, though, it's different. The data basically lives in one big shared pool that both the CPU and GPU can access instantly. Almost like, imagine 2 expert chefs working on one giant recipe book laid out on a massive counter instead of constantly photocopying pages and passing them back and forth.
Okay, so they're both looking at the same page at the same time.
Pretty much. That seamless, instantaneous access, it's a game changer for these enormous models because you spend less time shuffling data and more time actually, calculating the answer.
That idea, shifting from passing data back and forth to just accessing it together, that feels significant. So, okay, let's pivot to the big question. Why? Why do this locally? If the cloud offers effectively limitless power, why would a serious developer or maybe a company choose to put this mini supercomputer on their desk instead?
Right. And that really boils down to a few key things. Control, cost, and how fast you can iterate, how fast you can try things. Maybe we can use that baking analogy just for this comparison.
Okay, let's hear it.
So the cloud, that's like this huge industrial scale commercial bakery. They've got thousands of ovens, all the space in the world. They can bake anything you want, huge batches. But
But
you have to book your oven time way in advance. You submit your recipe, you pay for every single minute that oven is on. And crucially, if you suddenly realize, oops, I forgot the baking soda,
uh-oh.
you can't just run back and add it. You have to stop the whole process, submit a new order, wait in line again, pay for a whole new baking run. That friction, that delay, it can add days, even weeks to figuring out your perfect recipe, or in this case, your perfect AI model.
And you're not just paying for the oven time, are you? Getting your ingredients, your massive data sets into the cloud kitchen, and then getting your finished cakes, the results out again, those data transfer fees, the egress costs, they can sneak up on you and really bite into the budget.
Precisely. Those continuous subscription costs, and especially the cost of moving data out, they become really painful if you're doing a lot of experimental work, lots of trial and error. The DGX Spark, on the other hand, that's like having your own professional-grade high-performance oven right there in your kitchen.
Okay.
It might not have 10,000 identical ovens like the commercial bakery, but it's yours. You own it. You can try a recipe tweak, see it fail in minutes, and immediately try something else. Zero delay. Zero extra cost for that iteration. Zero waiting for someone else. You control the whole process.
Yeah.
And, this is critical, you control the ingredients. The data.
Ah, the data privacy angle.
Exactly. Super important. If the model you're training uses, say, sensitive company documents or maybe patient health records or some really cutting-edge confidential research, doing it locally means that data never has to leave your secure building. That's huge for privacy, for regulatory compliance. It stays put.
And it's not like you're stuck if your needs grow, right? The sources mention scalability. If you start with one and your project gets bigger, you can actually link two of these sparks together. Tackle even bigger problems.
That's right. It's designed with growth in mind. So it's a self-contained unit, powerful on its own, but you can pair them up. It allows the hardware investment to kind of scale up naturally as your AI ambitions get bigger.
So, sticking with the analogy, if the cloud is the giant commercial kitchen, who exactly is the chef that really needs their own personal pro-grade oven at home? I mean, this isn't for checking email, right? Who gets the biggest benefit?
Yeah, definitely not for everyone. But we can see, I think, three main groups who stand to gain massively almost immediately. First up, the independent AI researchers or maybe small dev teams. Think garage startups, university postdocs.
Okay.
Historically, if you had a brilliant idea for, say, a huge new language model, you either needed serious venture capital to pay for massive cloud bills, or you were stuck begging for time on slow, shared university computer clusters waiting ages.
Right, the resource bottleneck.
Exactly. This machine kind of democratizes access to that top-tier tooling. Suddenly, these smaller players get instant results, they get privacy for their unique ideas, and they get the ability to try things and fail quickly and cheaply. And that failing fast, that's absolutely essential for real innovation. Okay, second group, small companies or maybe fast-growing startups that are building actual AI products. They often hit this wall where they need serious computing power to develop their product, but they just don't have the cash flow for constant, high-volume cloud spending.
The burn rate problem.
Precisely. The DGX Spark can act like a vital bridge for them. They can do, say, 90% of their prototyping, their model testing, their fine-tuning in-house. It's a fixed one-time cost for the hardware instead of this relentless operational expense, the OpEx, that can really kill early-stage companies.
That control over ongoing costs, yeah, that's a huge incentive, especially if your funding situation is, well, volatile.
Couldn't agree more. And then the third group, which is also really important, is academic labs and teaching institutions. This is where the next wave of AI talent is coming from.
Training the future.
Yeah. And if students currently have to wait like 3 days just to get access to a remote cluster to run a fairly simple experiment, well, their learning just crawls, giving students direct, hands-on, immediate access to hardware that can handle supercomputing class workloads. It means they can learn faster, they can experiment more boldly, try working with real-world scale problems, not just tiny simulated ones.
And maybe let's bring this right back to you, the listener. Maybe you're a professional in a field that's starting to use AI heavily. Perhaps you run a creative agency or a design firm, and you can see a future where you need to fine-tune really specific custom AI models for your business.
Uh-huh.
Maybe it's a large language model trained only on your company's internal documents and knowledge base so it speaks your language perfectly. Or perhaps it's a custom image generator trained purely on your brand's unique visual style to guarantee consistency.
Right, that level of deep customization.
Yeah, exactly. That kind of demanding, high-stakes customization, it often takes thousands of hours of compute time. Trying to do that purely through external cloud services, it's not only potentially risky from a data privacy view, but it can get incredibly expensive fast. This kind of device lets you bring that really intensive, sensitive custom work fully in-house, under your control.
So stepping back, what's the big picture here? What does it all signal? I think the DGX Spark is a really potent indicator of just how aggressively hardware performance, localized hardware performance, is being pushed upwards. We're genuinely watching capability that was exclusive to real AI supercomputers become dramatically more reachable, less dependent on needing access to that massive remote cloud infrastructure, at least for the development and iteration phases.
It really does feel like a fundamental shift is underway. And even if you, listening right now, aren't planning on developing AI models yourself today, this device is a clear sign, isn't it? It shows how fast that line between the giant distant data center and your own personal desk is blurring. This whole trend towards powerful local control, towards instant iteration, it feels like it's going to unlock new kinds of applications. Things that maybe the friction, the latency, the sheer cost of relying only on the cloud might have held back until now. What new things become possible when that gap between having an idea and actually testing it drops almost to zero? That's really the fascinating question to mull over, I think. And we definitely want to hear what you think about this. If you suddenly had this kind of AI muscle right on your desktop, what kinds of demanding, maybe even crazy applications would you tackle with it? Let us know your ideas, your thoughts down in the comments section below the video. And hey, while you're down there, if you found this deep dive interesting, please do give us a like, share it with anyone else who might be interested, and definitely subscribe to the YouTube channel. It helps us keep bringing you the latest info and analysis on AI trends. Also, don't forget to hit that notification bell icon